Okay, we continue. There is an optional switch in FLAC2D and FLAC2D8 and FLAC2D9 that is B sleep, bounded sleep in the interface. Bounded interface in FLAC8 and FLAC9 is on, but that is not very real conditions. In this condition, B sleep on, sleep while bounded. That allow sleep to occur for a bounded interface segment, even though separation has not occurred. And shear yield is under the control of the friction and cohesion parameters, not friction, cohesion, and normal stress, just friction and cohesion. Okay, we can also B sleep off. In all software. B sleep off. B sleep off. B sleep off. B sleep off, and rebuild and check the result again. Okay. The deformation is different of previous deformation. And in the FLAC8, rebuild, save. Solve. Okay, bad geometry. Yes. Y displacement, maximum Y displacement in the FLAC2D8 is 3.25 meters. And in the FLAC2D9 is 3.04. And the result are very close in the vertical displacement, maximum vertical displacement. Also, we can check the plot of plasticity. Plasticity and grid. Here you can see different type of plasticity. This color is at yield in shear or volume. This area and these are yielded in shear or volume, but the green color area at yield in past. What is it? When we have a yield in past, that is means that at the beginning of cycling, yield occurred in the green area, but at the end of the cycling, it returned to the elastic conditions. And we can check the plot of plasticity in the FLAC9. Return to the label and choose the state. Here you can see plasticity, conditional, tunnel, around of tunnel in FLAC9. Okay, we return to the FLAC8 and activate the second scenario with cable bolt. Edit, 𝐸𝐸, bolt, import the bolt 𝐸𝐸 and go to the structure, cable. The number of segments are 4. That is one trick to assign cable bolt in a specific length and a specific degree to the surface, to the horizontal direction. It's done. Execute. We have cable bolts around the tunnel, and we go to the structure tab, structure element properties, and assign the properties of cable bolt. Area 5 E-4, space in the tunnel axis will be 0.8 meters. Mechanical parameters, young modulus will be 205 gigapascal. Yield, tension yield 5E5. Density and growth interface 1.5 E10. Bond interface 8E5. Okay, perimeter 0.0785. Okay, execute and run the model. There is a problem. We don't have excavation of tunnel. copy, save, paste here, rebuild. Okay, Control A, cut, and paste here, rebuild. Okay, it's done. Save and go to the plots, model, structure element, cable, cable axial force. Here you can see the cable axial force. Control P, setup in printer. In the view, print. Here you can see the plot of cable bolt in axial force. We have more axial force here. Maximum axial force is here in the fault area. Okay, we can check by displacement. We have 3 centimeters settlement here and 4 centimeters uplift here. Okay, let's go to the FLAC9 and start cable bolt for tunnel. Copy this code. Create a derivative file. Cable bolt. Paste. Rebuild. Okay. Okay, we write the codes of cable bolts. The diameter of cable bolt will be 25 millimeters with the length of 4 meters and a spacing of 1 meter. Okay. First of all, we must to import the DXF file about the pattern of cable bolt. After that, we will write the codes of structural element, cable bolt structural element. Okay, we start with geometry code. Geometry, import the name of DXF file. The name of DXF bolt.dxf. Okay. After that, we will write the codes of structural element. Structure cable import. Structure cable import from geometry the name of the DXF file bolt and also the number of segments of cable bolt I select 4 number for segments. Structure cable import from geometry bold segment 4. After that, we will write the property of structural cable bolt. Structured cable bolt property. We copy these words, these codes, and we will write structure cable property. Property cross sectional area 5e-4 𝐻 modulus 205e9 205 gigapascal. Yield tension will be 5e5. After that, growth stiffness will be 1.5 E10. Growth cohesion will be, also we can write with this pattern, with these codes, or continue coding in one row. 3 point here. After that, you can write the extra codes here in related to previous codes, related to these codes. Growth cohesion will be 8e5. Okay. So structure property, cross-sectional area, 𝐻 modulus, yield tension, growth stiffness, growth cohesion. Okay. We can rebuild and check the plot of cable bolt. Okay. We have a warning here. One newly created node didn't create links. Include node number 61. Node number 61 have a problem with the links with ground. Okay, we check the node number 61. Okay, we have here cable bolt plot. Okay, cable. Here you can see the number of nodes in each cable bolt. The number of node in each cable bolt is 5. 1, 2, 3, 4, 5. Because we have 4 segments. We selected 4 segments. Okay. We go on the cable group of element. We select label and we select the link, and we can see the problem. Okay. As you can see here, we have a green yellow here, and this part is free, and there is not any link here. Okay, there are problem here. Also, we can check the number of nodes with this option, and okay, the number of node is 61. Okay, turn on zoom, and we check in zoom in here. As you can see, we have a problem with the boundary of tunnel, surface of tunnel in the crown. If you remember, we changed the geometry and here for good quality of meshing, and for this reason we have a problem here. Okay, we must go back to the sketch and edit here. Okay, okay, zoom in, select these tools and zoom in and edit this point. There are a problem here in this with this node, and we can change the position. It's good, I think. Okay, and again we can mesh. Okay, good. Okay, keep or delete the existing zoom before creating new one. Delete. Okay, we must to repeat all operations in this stage because we delete the previous geometry and mesh. And we select inside of tunnel. I press Control on keyboard and select inside of tunnel and assign a group name, tunnel. Okay, select crash zoom or faulted zoom. Faulted. Faulted zoom. Okay, we select assign rack. I name it rack. Okay, select all model and assign a constituent model with more column criteria. Set model properties. Okay, density will be 2700. 𝐸 modulus 10 gigapascal. Poisson will be 0.27. Cohesion will be 0.8 megapascal. E6. Friction will be 35. Dilation 10 degrees. Tension 1.8. E6 megapascal. Okay, good. Save. Select this icon and ignore this icon group name, assign. Okay, we will have here the boundary, the name of boundary is here. Okay, surface, base, this, and top. the project. The model state is unsafe state. Okay. File override. Yes. Okay. We will go to initial and model new, model restore, mesh, and boundary conditions, model gravity, largest range, off, and rebuild. Check the plot of displacement. Okay, nice. Faulted zone. We don't need this course. Okay. And the cable bolt. Okay. Rebuild here. The geometry boulder is okay. The geometry boulder exists before. Okay. We have a structure cable bolt here and geometry of geometry import here. And so we delete structure cable, also geometry delete, structure cable delete, geometry delete, and again geometry import, again structure cable import from this. Okay, nice. And we can check the lot of link. Okay, sharing, it's okay. And model largest range on, model solve, and the model save, cable. Okay, rebuild. Oh, that's geometry. Okay, model largest range on. Okay, we have instability here. Okay. Okay. Okay, in FLAC 9, we have instability with cable bolt. It's strange because in FLAC 8, uh, with cable bolt is stable. Okay, no problem. We can model with the shotgrid, model new, the shotgrid. Okay, model new, model restore. Okay, model new, model restore, then delete, structure cable delete. Okay, model restore, zone delete, zone C model, property, zone face, zone separate, zone interface, structure cable bolt delete. We can write the codes of structure, shotgrid structure. structure, beam by zone face, range group